Please tell me that I can't, that I won't, that I fail, that I'll never make it out, yeah. Please tell me all the bad, never good, fill my head full of every single doubt, yeah.
Welcome to Chip Logic Studio, and in this video we will discuss about constraint must know interview questions, and it will be same for your UVM and SE. So understanding these examples of constraint, you should watch my full video and subscribe my channel if you haven't subscribed, and there is the bell icon. So let's start with our today's video. So first I will show you that our constraint works. Otherwise you will say that I am showing you one ChatGPT example without working. Okay, so let's see. Yes, so this is our pattern, and 10 10 10 and 001 and a different pattern. So all this example we will see. So let's go towards our example. So this is our example. First constraint is our 1010, and if you declare your n as a 4, it will be 1100. So this is example of multiple in patterns. With the same logic, you can generate this n 2 4 5 6 multiple of 2. These patterns you can generate. So these patterns you can generate with the help of declaring this n is our parameter. It is declared as a class as a parameter, and this value is, we will set as a 2 for now. So constraint and bracket our curly brackets, it is our syntax, and it has a name. Our pattern 1, we will say pat1, and this pattern we will declare that n is not 0. First of all, n is not 0 and n is multiple of 2, so this we will declare as first. Now, as our SystemVerilog has a wonderful loop, a for each loop, which doesn't need to declare an I as a variable, it directly take it, and we don't also have to declare any limit for that. It will directly take its limits. So let's move towards our constraint logic. So for each loop, this bracket is the syntax for constraint. For each loop, we will say that if I is less than n by 2, for example, our n is 2. N is equal to 2, so n by 2 equal to 1. So if I is less than 1, so first we will say when I is 0. So I is 0 means less than 1. So first condition, I equal to 1. Second, if I is 1 means, then it will go to else if loop. I is less than n. Yeah, it is less than 2, so it will be 0. As condition said, it will be 0, so 1 0. And the third condition, else pattern I, index I is equal to pattern I minus n. So I minus n means our n is 2. Now 2 minus I, our I is 2, and 2 minus n, it's 0. So our this 0 is 1. Again same thing, it will be 0, 1 0 1 0. So this is our pattern 1 0 1 0. We have known this pattern is 1 0 1 0, and we have arrived with our answer 1 0 1 0. So this is our simple assertion, which will say first declare 1, then declare 0, and we will repeat this thing with the help of our last condition. So simple, 1 0 1 0 is generated. If n is 4, you can just directly say that 1 1 0 0, it will generate 1 1 0 0, because it will be less than 2. Set up till 2, or our second index means 1 index, it will be 1 1 and then 0 0, similar to that. Let's move toward our next. So now we will generate pattern 0 1 0 1, and as our constraint is same, our for each loop is same, we will directly jump towards our pattern. So here we have taken our parameter as p. Now p equal to 1, let's say here p equal to 1. So if I is less than p, I is less than p means I at 0 index. So I will say I, it is index, its index is 0, is less than p, so it will say 0. Then I is greater than p now, because I is 1, because there is no equal to condition, it is just less than p, only the second condition. Now second condition is our I is greater than 1. Yeah, I is 1, and I is less than 2 into p. 2 into p means 2. 2 into p means 2, so it is between 1 and 2, so it will be 1, because our index is 1. So this condition is fulfilling here at the second, so it will be 1. So it will be 1, and as previous question, it will again say our index to our 0th index, because I minus 2p means our 2 minus 1, so 2 minus 2, then our index is again 0. So again at second index it will repeat the same thing, 0 1 3 0 1. So the pattern get repeated, 0 1 0 1. And if you change the value of our p equal to 2, then it will be generating 0 0 1 1 0 0 1 1. So similar as previous question. So next question is our generate pattern as 0 0 0 or 1 2 3 4 like that. So we will take our second example as p equal to 1, because you will understand this question after I explain the second part. First part is so easy. And so constraint is same. And what is another question is that if you want to start from 0 from all pattern, then have only this pattern. Okay, so let's see here first. So as our for each loop is there as always, and if I is less than p, so because I is 0 now, so I less than p, so it is 1, so our answer is 1. Else our pattern xp I by p means 1 by 1 plus 1. 1 by 1 plus 1 means 2. 1 by 1 2 by 1 equal to plus 1 3. So it is simple question, very simple. So generating pattern 1 2 3 4, and similarly if you 2, so it will repeat 1 1 2 2 3 3 4 4. So you can understand this with the help of these two lines. If else condition, we can generate this pattern. Now question number 4 is 0 0 1 0 0 2 means our third index, or you can say in your second index, because we start our numbers from 0. So this is our pattern and our second index is always increasing. So let's say this for each loop is same, constraint is same. If I is percent of 3 means our remainder is 2. So whenever 3 is divided by something, the remainder is 2 means, okay, let's say I is our 0. I is our 0. What is happening in 0 is that I by 3 means 0 by 3 is 0. So our remainder is not 2. So answer will be 0 as our second condition. Second, 1. Our index is now 1. So I 1 by 3. Our remainder is not 2. So again answer will be 0. Now 2. Now 2 by 3. Our remainder is 2 because 3 cannot divide it. So it will be 1 as our condition. It will be 1 by 3 plus 1 because remainder is 0, and because it cannot divide, so I by 3 remainder is 0 because we have declared as a bit, you can assume, and bit or int anyway, it will be 0, and 0 plus 1 is 1. Now third index, again 3 by 3, our remainder is 0, 0. 4 by 3, our remainder is again not 2, so it will be 0. 5 by 3, then 3 1s are 3 and 2 is our remainder. So what is our condition? 5 by 3 means our remainder is our 1 because it is integer or bit. So 1 plus 1 is 2. So our pattern is generated 0 0 1 0 0 2. So if you declare pattern I by 6, something of multiple of 3, then this pattern can be generated. So now our next question, fifth question. Oh, fifth and sixth question both. Okay, fine. So our pattern is 0 1 0 2 0 3. Similar to our previous question, for each loop is same, and it is saying that multiple of 10. So first is 0 1, so second is 10 20 30 40 like this. So simple is pattern is I into 10 because 0 into 10 is 0, and then 1 into 10 is 10. So and 2 into 10 is 20, so something like 0 1 0 2 2 0. So this pattern is generated. This simple question. And this last question I have included because if you don't know anything, just generate if then condition, if else if nested if else, and you will generate your pattern. For example, if saying 0 1 0 0 1 1 0 0 1 1, if you doesn't something come to your mind any logic, see if 0 index is there, just say it is 0. Index 1 is there, just say it will be 1 because our pattern says 1. If it is 2 or 3, then it will say 0 0 as our condition. 2 or 3 is there, so inside our 0. If 4 or 5 is there, because it is 1 1, so we will say 1 1. So if something doesn't come to your mind, just declare as equals, and this is also our right approach. So thank you for watching this video, and we will meet at our next video, and thank you.
Say any negative thoughts, I pop off when I hear people say I cannot. I get off to the thought of proving everyone wrong. I won't stop to the top, so you better back off and get lost.